In Unit 8, we are going to eventually be solving some radical equations and inequality. So before we get into working with those, we're going to review how to simplify and add, subtract, multiply, all those things with radicals. We already talked about this in first semester, but just a quick review here. So remember, when we're simplifying radicals, what we're looking to do is we're looking for the largest perfect square that divides into the radicand, okay? So we're looking for, like in this case, 12. The largest perfect square that goes into 12 is 4. So we would say 12 is 4 times 3. We're taking the square root of these things. The square root of 4 is 2. And then we can't do anything with that square root of 3. So that's it, okay? If we look at number 2, negative 2 square root of 32. So simplify 32. The largest perfect square that goes into 32 is 16. Right? So square root of 16 is 4, and then square root of 2 we can't do anything with. And we have that negative 2 hanging out front. So negative 8 square root of 2. Okay? And then for number 3, 5 square root of 36. 36 is a perfect square. The square root of 36 is 6. So it's just 5 times 6, which is 30. Okay? So that's what we're working with. Now, to add or subtract radicals, we have to have like radicals. Okay? Meaning same index, same radicand. So when we have that, we just add or subtract the numbers that are in front. So that becomes 11. And then we keep these the same. So this just stays square root of 6. So 11 square root of 6. Okay? Something like number 5, where our radicands are different, we can't combine them. But before we just say we can't do anything, we check to see if we can simplify. So biggest perfect square that goes into 12 is 4. And then 27, the biggest one would be a 9. So 9 times 3. So we've got 5 square root of 3 plus 4 times, and then 2 square root of 3, right? Square root of 4 is 2. Square root of 3 minus, and we've got that 2 times, and then square root of 9 is 3, and then square root of 3. So as we simplify this, 4 times 2, so plus 8 square root of 3 minus 6 square root of 3. And if we combine these now, 5 plus 8 is 13, minus 6 is 7 square root of 3. Okay, so that's what we're working with there. Same deal with number 6. As we go through, in this case, 5 squared root of 25. 25 is a perfect square. So that just becomes 5 times 5 minus, here, 25 goes into 50. Right? So let's work with these, simplify these. And then 32, we've done this one already, 16 goes in there. So what we'd have here is we'd have 5 times 5 is 25 minus 12 times square root of 25 is 5, and then square root of 2 plus 6 times square root of 16 is 4, square root of 2. So 25 minus 12 times 5 is 60, square root of 2, plus 6 times 4 is 24, square root of 2. So now these two are like radicals. We can combine those so that 25 just chills out front, and that would become minus 36 square root of 2. Okay? And that's as much as we can combine. Okay? So that's what we're working with there. Now, multiplying and dividing. They just have to have the same index to multiply or divide. So when we multiply here, like in number 7, we're going to take the numbers outside and multiply those. So 3 times 4 is 12. And then we're going to take the radicands and multiply those. So 3 times 6 is 18. And once we do that, we just check to see if we can simplify, which 18 is 9 times 2. So we could say this is 12 times 3 square root of 2, which would be 36 square root of 2. Okay? Now when we get into division, we're going to divide everything we can. So as we work with this, I'm going to write this a little bit bigger here. So 12 square root of 12 over 4 square root of 6. So as we look, we want to divide anything we can just to make it easier on ourselves. So 4 does go into 12 3 times, right? And those are both outside, so we can divide those. And then 6 goes into 12 2 times, and those are both underneath the square root, so we can divide those. So what we have left is 3 square root of 2 over, and then 1 square root of 1, which 1 times square root of 1 is just 1. So we just get 3 square root of 2. Okay, so that's what we're working with there. Now, one like number 9, we're going to simplify the top first, and then we can go from there. So if we multiply in the top, 2 times 7 is 14, and then 5 times 6 is 30 over 7 square root of 2. And then we do the same thing. So now the numbers outside, 7 goes into 14 twice. 2 goes into 30 15 times. So what we've got on the numerator, 2 square root of 15 over 1 square root of 1, which would just be 2 square root of 15. Right? And that's what we got. So that's how we're going to multiply or divide. Now, issue again becomes when we have a radical left in the denominator, right? That's where we have to do what's called rationalizing the denominator. So what we do is we multiply by the radical that's in the denominator. So multiply the top and the bottom by the radical in the bottom. So the numerator becomes 4 square root of 2 over square root of 2 times square root of 2 would be square root of 4. And the square root of 4 is 2. And then now that we've done that, we can actually divide those out and say 2 square root of 2 over 1 is just 2 square root of 2. Right? The goal of rationalizing the denominator is to get the denominator to be a rational number, so no square roots left down there. All right? Now, one like number 11, square root of 10 over square root of 6. Okay, again, first thing, reduce if we can, divide if we can, right? So if we look, we can actually divide out a 2 from both of those. So we can make this the square root of 5 over the square root of 3, okay? And then now we can worry about rationalizing, so we're going to multiply by the radical that's in the denominator. So that would become square root of 15 over square root of 9. Which the square root of 9 is 3. So square root of 15 over 3, okay? And if you don't rationalize it, or if you don't simplify at the beginning, and you just work with square root of 10 over square root of 6, and you go that way, right? You're still going to get the same answer. You're just going to have a little bit of simplifying to do at the end, right? So we get this. So we end up with square root of 60 over square root of 36 if we don't reduce at the beginning, which in this case 60 can be broken down, that's 4 times 15. So the top could be 2 square root of 15 over, and then in the denominator that'd be a 6. And in this case we can divide out a 2 and make it 1 square root of 15 over 3, which is what we got here, right? So you get the same answer, it's just you save yourself a step at the end. Okay, if you try and divide out stuff first. Now, last one, again, same thing. Try to divide stuff out first, because in this case, we can divide out a 2 and make this 5 square root of 3 over 2 square root of 1, which would just be 5 square root of 3 over 2. And we don't even have to rationalize because it cancels out. So we're good, okay? So again, just a review of working with some radicals. So try out that homework and let us know if you have any questions.